Our last section is about our solar system, the order of the planets, and also distinguishing characteristics of each. Alright, so at the center of our solar system is the sun, in which all of the planets revolve around. So if we were reviewing, I would ask you what this here thing is, and you would tell me it's a prominence. Right, good job. First up in our solar system are the inner planets. The inner planets are also known as our terrestrial planets. So terra means ground, earth. They're rocky planets. Okay, so it's Mercury right here. Then we have Venus, then we have Earth and Mars. And all of these planets consist mostly of solid rock and have metallic cores. That's why they're grouped together. Mercury is the first planet in our solar system. It is a terrestrial planet, and you will learn much more about it in our next activity. Venus, it's also known as the evening star or the morning star because that's when it's mostly visible. It is our twin planet. It's almost the same size, mass, and density as we have, except that it's not hospitable because it's the greenhouse gas planet, meaning it's really hot. It traps a lot of heat inside. Earth, third planet in our solar system. I shouldn't have to say any more because we're in Earth science and we've been studying the Earth all year. Mars, the fourth planet in our solar system. Mars has seasons much like we do, and because it is also a tilted planet. It also has volcanoes, and there is evidence that suggests that there was once water, so possibly also at one time life. All right, the asteroid belt comes right after Mars. You see right here, here's the orbit of Mars, here's the asteroid belt. It kind of serves as a dividing line between our terrestrial planets and our gas giants. It's a beautiful way to have our solar system organized. All right, the next set of planets are outer planets. They're also known as the gas giants because they're huge and they're made of mostly gas. They are separated from our inner terrestrial planets by the asteroid belt. They are much larger, but they don't weigh as much. And all four of these gas giants, whether you can see from this picture or not, have a ring system made of dust and icy debris. Jupiter, the fifth planet in our solar system, has at least 60 moons, and it has this giant red spot, which is a gigantic rotating storm. Saturn is known for its beautiful ring system. It has the most complex and extensive one out there, made up of dust and ice particles, and Saturn also has at least 30 moons. Uranus comes next. It rotates almost parallel to its orbit, meaning at one time it was knocked on its side. So Uranus also has at least 24 moons. So you can kind of start seeing a pattern here. A lot of these outer planets have a lot of moons as opposed to the inner planets have few or no moons. Neptune, the eighth planet in our solar system, contains the solar system's strongest winds up to 1,000 kilometers per hour, and it too, very similar to Jupiter, has a spot. We call this one the Great Dark Spot, and it's also a large storm, and it's actually about the size of our Earth. Pluto is next up in our solar system, although it's no longer considered one of the planets. Pluto only has one moon, and it's very, very cold out there. So as you know, the new classification leaves poor Pluto out of our solar system, or out of our planets, not out of our solar system. Some ways that you can use to remember the order of the planets. The one I learned when I was growing up was my very educated mother just served us 9 pizzas. So my stands for Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and then Pluto. I always include Pluto just because it's good to know where Pluto is still. All right, beyond our solar system or beyond Neptune is this region called the Kuiper Belt. So it contains icy bodies that could be the source of some short period comets. So there's also another planet out there called Eris that is a part of the Kuiper Belt. And you can see in this picture here, it's just this belt of icy bodies and rocks and things like that that exist outside of our solar system. All right, the Oort Cloud is the cloud where comets reside. All right, it was proposed by Jan Oort. No comet has been observed with an orbit that indicates that it came from interstellar space. So they're saying that comets are arriving from all sorts of directions. So if you look in this picture here, this cloud-like thing is the Oort Cloud. All right, here's a better diagram of it. So you can see this little area right here is our solar system, and this Oort Cloud, this large cloud of all these dots, is where all the comets are coming from. So you can see that it surrounds our solar system on all sides.